Okay, so sigmoid was one. Then we have some other variations as well. We have tanh, we have ReLU. And again, it depends like what kind of use case you have. So the intermediate layers, more or less, it doesn't matter actually. You can try different activation functions. Again, ReLU is a very interesting one, which works pretty well. One very interesting aspect of this activation function is, what if you are going to use them on your final prediction? And then there it actually matters which activation function you want to use. All right. So for example, if you want to make prediction about some objects, let's say it's a classification problem, then having a ReLU activation at the end, it won't make that sense, because what it's doing is it's giving you values between 0 and infinity. So if you have a prediction value between 0 and infinity, it will be very hard to interpret like those values. Okay. For example, let's say if you get a value of 10, you can say, okay, 10 seems like a positive number, so this class might be present. But what if like in the next run you get like a value of 1000, then how will you compare those two? And in the next, if you get, let's say, 100,000, so compared to 100,000, 10 is nothing, right? So in that sense, ReLU might not be that useful. So in that case, sigmoid might be useful because it's actually bringing them between 0 and 1. So then it's kind of normalized. So you can say that if it's closer to 1, it seems like positive. Closer to 0 seems like negative. And if it's like, let's say 0.5, then it's kind of confused. Okay, so then sigmoid might be a good activation function there. And now tanh has, again, very interesting use case there. If you, let's say, are trying to solve a binary classifier, all right? And in binary classifier, you don't want to use 2 neurons. Let's say you just want to use 1 neuron. And again, of course, you can use sigmoid for that as well, but tanh could be pretty interesting because what it will do is, for one class, it might predict negative values. And for one class, it might predict positive values. So it will be pretty easy for you. You can just check like the sign of the value, what the network is predicting, and that will tell you the class. And of course, you can do that for sigmoid as well. You can argue that, okay, what if I just like use 0.5 as a threshold? And if it's greater than 0.5, it's a positive, otherwise it's a negative. And that's entirely true. You can of course do that. But if you look at if you look at like these curves carefully, the non-linearities in these two is slightly different. So that will make a difference, and it might affect like the performance you have. And again, it's very hard to say that which of these will be better. You'll have to test and try that out. Okay, so yeah, I think we covered these points. So this is also good. We know like if it's a binary classifier, you can use single output or you can have 2 outputs. And for multiclass, you can have multiple neurons which will make predictions.